In this video lecture, I will solve another design problem for T-beam. So this is our example problem. The slab is 3 inch, the beam wave width is 15 inch, the reinforcement location from here is 21 inch, center to center spacing between T-beams is 6 feet. Span, that means that way the length of the beam is 18 feet. Moment due to dead load is 200 cubic feet, and moment due to live load is 425 cubic feet. 3 KSI concrete, 60 KSI steel. Now the question is design this T-beam. Design means what is the amount of reinforcement in this beam. So that we need to do it. Before solving, I laid out the steps. If you saw my previous videos, I wrote these steps in details. So I will recommend before watching this video, you must watch the previous one so that you can understand these steps better. I wrote here shortly. So step number 1, we have to calculate load. Step number 2, calculate factored moment. So my load, I do not need to calculate my load because it is all my moment is already given. So I need to calculate my factored moment, which is 1.2 md plus 1.6 ml. This also 1.2 200 plus 1.6 425. So my factored moment will be 920 cubic feet. Again, I am solving this problem from your book. It is already solved in the book. I am doing it like step by step so that you can follow better. So we got our factored moment 920 cubic feet. Then size. We know this size. Our next size is to determine the width of the flange. So what is this distance? We need to find this. How to find this? If you read your book at the beginning, there are 3 conditions. Is that B cannot be greater than span over 4. So what is span? 18 feet times 12 inch divided by 4. That means 54 inch. Their other condition is that B cannot exceed the center to center distance. Or in your book they explained in defined way is that from here to here it cannot go 50%. It cannot go the middle of this. So the meaning is simply CC distance, center to center distance between these two T-beam. What is that? That is 6 feet, so 72 inch. Other condition is BW plus 16 AC. That means B cannot exceed, in both sides, it cannot exceed more than 8 AC. This side also 8 AC plus this BW. So it cannot exceed this. So if I write 15, 16, 3, it looks 63 if I am not wrong. Okay, let me check with your book. Yes, 63. So B will be the smallest. So our B is 54. So we got B is 54 inch. So size is done. I will delete it to save some space. So we got our size. Next step, we will assume A is HF. That means my A is inside my flange, and we will assume phi is 0.9. Next, we will check this. Then we will calculate our trial. It's a trial. It's not exact because it has some assumption. Trial reinforcement. So my moment is 920 cubic feet times 12. So cubic inch. P is 0.9. Fy is 60. D is given. Now what is D? D is from this point to this point. 21 is given, so another 3. So 24 actually. So D is 24, A is 3 by 2. Why I multiplied 12? To make it keep inch. My moment was keep feet. So if I solve it, in fact I am taking the result from your answer, from your book, it is 908. So we got 9.08 inch square. So this is my trial reinforcement. Then we will calculate our compression area in concrete. That means if I draw this T-beam, so if my compression area, what is my compression area? We will calculate this. How to calculate? Equation is given here. So 9.08 from this value times 60.85 A prime C. A prime C is 3 KSI. So KSI. So this will balance. If I do this, I got 213.6 inch square. This area is my compression area in concrete. Now, is this area within the flange, like within this flange, and this called is wave. So if this area is within the flange or it came inside wave, we need to check that. So to do that, we have to find our A. A means the depth of the compression block, you know that. Okay, so this portion is 54 inch, this is 3 inch. So what is the area of this flange? Area of this flange will be 54 times 3, 162 inch square. My area of flange is 162, if I am not wrong, 162 inch square. My area of compression is 213. So I have some area here also. What is this portion? Say this portion is X. Okay, so what is the balance? Balance is 213 minus 162. So 13.6 actually. If I deduct it, 6, 1, 5. So 51 inch square. That means area of this portion is 51 inch square. Divided by this portion is 15. So if I divide it by 15, I will get my X. What is that? If I use my calculator, 51.6 divided by 15, I got 3.44. So I got this portion is 3.44. This portion 3.44. So total A will be 3 and 3, 6.44. That means, okay, we got our A. Next step, is our A is smaller than or equal to A shape? Now what is A shape? A shape means the depth of the slab. If I do not tell you earlier, A shape means depth of the slab. So this case or this case, in last video I solved an example which is this case. This time it is this. My A, what is my A? We just calculated 6.44 inch. 3 is 3.44, 6.44. So this is my case now. So what happens if this is the case? I explained it in previous video. What happens if this is the case? Now I am going here. So we need to calculate Y bar. So what is the centroid of this area? We have to calculate it. Then we can calculate our revised reinforcement. mu phi Fy d minus Y bar. So last time we used A by 2 because we assumed that our A is within the flange, but A is now composite. The centroid of that portion is no longer A by 2. It is Y bar. So that is the revision. We can further revise. So we can again calculate the revised. Okay, we will go there. So first do this portion, centroid of this portion. Okay, how to find the centroid? So if I forgot the area of this, it was most probably, okay, I will write it here. So area of this was 162 inches square. Area of that portion is 51.4 inches square. So we will find the centroid of this portion. Say this, or make it clean so that you can understand better. So this is say 1, this is say 2. This portion is 3 inches square, 3 inch, this is 3.44 inch. The area of this is 51.4 inches square. Area of this 162 inches square. So my y bar will be y1, a1, y2, a2, a1 plus a2. What is my y1? Centroid of y, this portion. So centroid of this portion is 1.5 because 3 inch, half of this, area is 162. Centroid of, then y2 is centroid of this, here to middle of this, that means 3 plus half of this. Okay, 3.44 divided by 2 is 1.72 plus 3, so 4.72. 4.72, and area of this is 51.4, and a1 plus a2 is simply 213.6. Okay, so then we will get our y bar. If I do the calculation, it will be 2.28. 2.28. Okay, so hopefully you understood this part. This portion is just the revision from your statics class. Centroid of this, if I delete this, centroid of this portion, simply centroid of this this composite section. Okay, so once we get it, we can find also this portion is got done, 2.28. Then we'll find a revised reinforcement. Okay, so I will erase this portion. So revised reinforcement will be 920 times 12, keep inch, divided by 0.9, then 60, D is 24, Y bar is 2.28. Then my revised reinforcement is 9.41, 9.41 inches square. Now this reinforcement and previous reinforcement almost not, there's a gap or very close. Whatever you explain to my logic, it is almost same. Or if you think it is not same, no problem. It depends on person, individual judgment. To my logic, it is not same. We can revise it. How can revise? Revised AC. How to find revised AC? Using this equation. So we will use this equation, bring it here, and find our revised AC. In that equation, we will use this reinforcement. So AS will be that. Then we can calculate. That means simply we will repeat this two step here. Revise AC, revised A. Then we will find our revised Y bar. Whatever we did here. So this portion we can do it if we want to fine tune it. But this time I will skip because that will not help me so much. Okay, so hopefully you understood what I mean, that I can revise my AC, I can revise my A, then I can find my revised Y bar, whatever I did, then I can, so these two steps are here. And these two steps are here. So we can repeat these steps to fine tune it. So now I will go with this. Once we got, then we have to check our minimum reinforcement and phi. So minimum reinforcement, what is that? You know that, okay, I will erase here. So minimum reinforcement, we know that our code says minimum reinforcement should be 3 F'C Fy BWD, or 200 FYBWD. Now this time my BW should be 15. Do not make mistake here, it is no longer that B. This is BW. Okay, so if I solve this this two equation, I'm taking value from your book to save some time. Oh, your book did not solve it, so I have to do it by myself. Okay, so 3,000, 3,000, 60,000, 15, 24. So 3 times 3,000, 15, 24. If I'm not wrong, it is 0.98 inches square. Or 99, doesn't matter. So 200 here. Again, in this equation, this value must be in PSI. So BW 15, D is 24. In this case, my minimum reinforcement is 15, 24, 1.2. Yeah, these values are typically like this. If I make calculation mistake, that is okay, but I believe that it is correct. I'm doing quickly. Now, if it is whatever it is, oh, I deleted my reinforcement. It was somewhere here. I forgot it. Yeah, most probably my reinforcement was 9 point. Okay, let me see your book. 9.41. So my reinforcement was 9.41. Yeah, my reinforcement is way higher than this. So minimum reinforcement is okay. So this check is done. Then phi. How to find phi? To find phi, you know that we have to find our A first, then beta 1, then C, then epsilon T, then phi. These are the steps to find phi. We will do one by one. Okay, I will delete this portion to save some space. I will take from your book so that I can do it quickly. A, if you can remember, our A was 6.44 inch. What is my beta 1? If you can remember, it is 3 KSI concrete. 3 KSI concrete. That means my beta 1 equation was 0.85 minus A prime C minus 4,000 divided by 1,000 times 0.005. There was an equation similar to this, if I am not wrong. Yes, there is equation. Your book just simply use beta 1 is 0.5. Now, so if we do this, beta 1 will be 90. This equation shows, or not point here, this equation shows beta 1 is 0.90, but we know that beta 1 can be 0.65 to 0.85. It cannot go more than this, it cannot go less than this. So 0.90 is not possible, we will use 0.85. So beta 1 is 0.85. What is C? C is A by beta 1. 6.44 divided by 0.85. I got 7.58. Then epsilon T. If you can remember how to find epsilon T, it is D minus C divided by C, 0.003. So D is 24. C is 7.58. 7.58, 0.003. What is my epsilon T? If I do the calculation, 0.0065. 0.0065. Now what is my phi? If you can remember how to find phi, so if I delete this portion, if you can remember this curve, phi is 0.9 here, 0.65 here. This value is 0.005. epsilon t. If epsilon t is greater than 0.005, p is 0.9. That means my value is somewhere here. So p 0.9 is good. Okay. So p is 0.9. Okay. That means our design is done. We did two calculation, 2.6, we did it. So our reinforcement 9.41 inch square is our final design. Okay, so design is done. We need to select some reinforcement and place it here. You can select the bar, number of bar and size. Make sure that you can accommodate into this 15 inch and leave some. If you want to discuss more, it will be like longer, but I will go very quickly. So this portion is 15 inch. So I have to deduct some space here, for clear cover. So 2.5 inch here, 2.5 inch here. So I have 10 inch space. So inside 10 inch, if I select some reinforcement from your book, appendix, if I go to appendix, so 9.4 on, 9.4 on, is very tough because so I am getting 8 number 10. So 8 number 10, if I provide this 8 number 10 by reinforcement will be 10.12. You can see here, whatever the calculation shows, we cannot provide that exact amount. This is why when we were talking about fine tuning, we did not do that fine tuning, because we know that if we do the fine tuning, 9.45 will be say 9.55. But still though, when we provide it, we provide way more. So if we provide 10 number 8 bar, it is 10.12. So if you want to provide 10 bar in 10 inch space is very difficult. So we need to bundle. So yes, we need to bundle 8, but again 8 number 10 bar is not a good size to me. I will decrease the bar number. Yeah, there is actually no option. If I provide say 5 number 14, but again use, yeah, this is the closest option. So okay, we will bundle it. How to bundle? So if we do say 3 together, another 2 together. So we will do this 3 bars here, 2 bars here, 3 bars here. Then we have to check the minimum spacing between two bars. I think that should be okay, because we will have sufficient space. But again, ideally, as I said, you have to find the minimum spacing here. It must be at least 1 inch or bar diameter. Bar diameter means the combined diameter of this 3 bar. So yeah, that is detailing. I'm not going there to waste my time. Our main concept is how to design T-beam. Detailing is like another topic. I already discussed it many times. I will discuss it again in another video. So hopefully you learn the T-beam design. If you are at the beginning, we will assume our A is inside this. A is somewhere here. Then we will check if it is less than this, then one condition. If it is more than this, other condition. So this video and the previous video, these two video combinedly will will give you the both scenario of T-beam design. So in the next video I will solve more problem. Thank you.